Good day, ladies and gentlemen. This is Sarel van Grennen, aka Mr. VG, and we are now diving deep into grade 10 statistics, looking at grouped data. In this video, we are going to look at determining the estimated mean of a grouped data set. Now, when we look at this kind of sum, it could be a class's marks or a grade's marks out of 35 for a test, for instance. It could be anything. We don't really know because it was not given to us. The question that they're asking me for is the estimated mean. Why do they ask the word or use the word estimated? We use the word estimated because we don't really know what the actual data was. We just know there was one kid that got between 0 and 5. There were 5 of them that got between 5 and 10. There were 4 of them that got between 10 and 15, etc. So we don't really know what their actual values were, but we can kind of roughly guess what their actions were, or what their values were, not their actions, their values were. And for me to kind of guess what they were, I'm going to make a very, very, very bad assumption. But remember, we're working with estimates and not actual values. So to get the estimates, we need what we call the class middle value. The class middle value is the value that is exactly in the middle of 0 and 5. And what number is exactly between 0 and 5? Come on, ladies and gents. That's 2.5. Now, if you want, what a formula, sir. 0 plus 5 over 2. What we are basically assuming in determining estimated means, what we are basically assuming is that all of the kids that got between 0 and 5 got exactly 2.5. That is what we are assuming. Is it right? We have no cooking clue. We don't know. We have no idea, but that's our assumption. And the same we are going to do in the second class. The number exactly between 5 and 10 is 7.5. So now we're assuming that those 5 students that got between 5 and 10 got exactly 7.5. And that we are going to do with all the different values. So I'm going to go 12.5, 17.5, 22.5, 27.5, and lastly, 32.5. But for me to do mean, remember, I actually need to add up all the values. So I'm going to have to say there was 1 2.5. There were 5 7.5s. There were 4 12.5s. So what I'm going to do, and that's why there's another column in there, is I'm going to say fx. Now, it's not f of x. We're not talking about graphs here. We're talking about taking your frequency and multiplying it by the class middle value. In other words, just saying there was 1 2.5, which means if I add up all the 2.5s, the value of that is just 2.5. The same with if I say 5 times 7.5. So in other words, adding up all the 7.5s, my answer is going to be 37.5. So that's what I'm doing. I'm saying the frequency multiplied by the class middle value. Simple and straightforward. I'm going to repeat this process with all of the different rows. I'm assuming there are 4 12.5s. There are 35 17.5s. But for me to go now answer the actual question, which is the mean, there's a fancy formula, ladies and gentlemen, for the mean. It is sigma of fx. Whoa, what does that mean? Well, sigma of fx means the sum of all the fx's. That's what sigma, that capital, that funny looking E thingy looks like, means sum of. So I need, number one, how many students there were, or how many people there were. So first of all, n is 85, because if I add up all the frequencies, they are 85. Now I need to sum up all the fx's, and I get 1767,5. So that means my mean is going to be 1767,5 divided by 85, which gives me an estimated mean of 20,79. If we sketch the scenario of this is a grades marks for a test out of 35, then I can say that if I pick someone at random, they would have gotten 20,79. Is this accurate? Not at all. We don't know. But it is an estimated mean. Ladies and gentlemen, remember, statistics is not an exact science at all times. Sometimes it is exact, but it's not an exact science, because statistics is a tool for us to take what has happened in the past and try and predict what's going to come in the future. That's the real power of statistics, is we want to analyze what happened, you process that data and predict what is coming. That is the value of statistics. So it's not always going to be exact, and we don't actually want it to always be exact. We just want to take a very good look at what is happening in the data set. And this would tell me that, well, on average, that person got 20,79. Does it really make any difference? Well, we don't know. The power of statistics comes in when we can compare this, say, to another grade, or a year from a previous grade, or this is what we expect kids to be getting, so a universal standard. Then, and only then, does statistics really start becoming powerful. Wow, I love stats. Okay, I love it. But it's sometimes a fly in the ointment for pure mathematicians, because pure mathematicians want everything to be exact. But this is not always exact. So, I love statistics. Even though I love mathematics, statistics is so beautiful because of what the stories we can start telling about data. Ladies and gentlemen, please tune in to our next video, which is going to be again about group data, but looking at means and medians and quartiles, or not means, sorry, quartiles and medians. We've already done means here, so please tune in to our next video. This is Mr. VG signing out. Keep well. Cheers.